What is probability? Probability basics and definitions. Probability is used in many aspects of our lives, whether we think about it or not. What are the chances you'll get into an accident today? Will it rain today? Will I win the lottery? How much do I have to pay for insurance? There are many definitions in probability that are important to develop a conceptual understanding. This conceptual understanding is important in order for us to be able to calculate and solve problems regarding probability. So what is probability? Probability is a measure that's associated with how certain we are of outcomes of a particular experiment or activity. An experiment is a planned operation carried out under controlled conditions. If the result is not predetermined, then the experiment is said to be a chance experiment. Flipping one fair coin twice is an example of an experiment. A result of an experiment is called an outcome, and an event is any combination of outcomes. Uppercase letters like A and B represent events. For example, if the experiment is to flip one fair coin, event A might be getting at most one head. The probability of event A is written P parentheses A end parentheses. Let's talk fundamentals of probability. A sample space is the set of all possible outcomes for an experiment. It's an actual listing of the outcomes that are possible. You can represent a sample space in different ways. You can just use braces, like normal mathematical listing, or you could use a table, you could use a Venn diagram, you could use a tree diagram, or you could even use a chart. Here are some examples of coins and spinners. What are some probability rules? The probability of any outcome is the long-term relative frequency of that outcome. Probabilities are between 0 and 1 inclusive, that is 0 and 1, and all numbers in between these values. The probability of A equals 0 means that the event A can never happen. It would be considered an impossible event. If the probability of A is equal to 1, that means the event always happens. It would be a certain event. If the probability of A is 0.5 or 5/10 or 1/2, that means the event A is equally likely to occur as to not occur. Here's an example. If you flip one fair coin repeatedly from 20 to 2,000 to 20,000 times, the relative frequency of heads approaches 1/2, the probability of heads. That is Bernoulli's law of large numbers. The more times you repeat an experiment, the closer the relative frequency approaches the theoretical probability. What is the complement? Usually we use a little tick mark. The complement of event A is denoted A prime. A prime consists of all outcomes that are not in A. And if you add the probability of A plus the probability of not A, you should get the total probability, which would be equal to 1. So for example, if the sample space is 1, 2, 3, 4, 5, and 6, and set A is 1, 2, 3, and 4, then not in A would be 5 and 6 because they're still in the sample space, but they are not in the set 1, 2, 3, 4. Set theory comes into play with probability a lot. Here's some problems to try. Find the sample spaces for the following. A single die is rolled, 2 coins are tossed, 2 dice are rolled, and they're just 6-sided dice. The genders from the birth of 3 children, 3 coins are tossed, and then after you try those, look at the answers. So pause this video, try to write the sample space for each one of these. Did you get them right? Here's the sample spaces. So if it's a single die, the outcomes are 1, 2, 3, 4, 5, and 6. If 2 coins are tossed, you could get 2 heads, a head first and then tails, a tails first and then heads, or 2 tails. There are the outcomes for if 2 dice are rolled, and the genders, and then if 3 coins are tossed. You should be able to write out sample spaces. Here's some fundamentals of probability. The probability of an event occurring is the number of outcomes of that event divided by the total number of outcomes. You can try the following problem. A single die is thrown. What's the probability of rolling a number that is A, divisible by 2, B, divisible by 3, C, greater than or equal to 5, D, it is prime, E, it's a 7, or F, it's less than 7. Try those problems and then continue the video and compare your answers. So divisible by 2, well, those would be the events 2, 4, and 6. So there's 3 of them out of a total possibilities of 6, which simplifies to 1/2. Divisible by 3, that's 3 and 6, so there's 2 of them over the total possible, which is 6, which simplifies to 1/3. Greater than or equal to 5. There are 2 outcomes that are greater than or equal to 5, which simplifies to 1/3. Prime, now be careful, don't forget that vocabulary. 1 is not a prime number. Prime numbers have exactly 2 factors, and 1 only has 1 factor. So it's 3/6, or 1/2. What's the probability that when you roll a single die, you get a 7? Well, that's the empty set, or 0. There are no outcomes that would be a 7. So there are 0 events out of 6 total in the sample space, which simplifies to 0. And the last one, a number less than 7, well, that would be all of the outcomes. So 1, 2, 3, 4, 5, and 6. So 6/6, so the probability would be 1. So F is a certain event, and E is an impossible event. This is just the beginnings of probability. So I hope that this gives you an idea of some of the vocabulary.